Hello everyone, this is my fourth experiment, statistical inference. My first question is, calculate the sample mean for price column with n is equal to 500 and we have to observe it. So first, importing the libraries, reading the file, and then I'm just declaring the variable and giving that before my question, they have given that taking the data till the value is good, cutting the data till the value is good. Then if the price dot sample, then giving 500 value, then calculating the mean. Then the R value is sample mean is equal to 4018.046. Our second question is calculate the sample mean for price column with n is equal to 1000 and observe. Here we are gonna check n is equal to 1000 and we are checking for the mean value. So mean is equal to 4002.93. Our next question is calculate the population mean for price column. We are going to calculate the population mean. So giving the population column inside this and we are calculating the mean. So our value is 3928.8644. Our next fourth question is calculate the confidence interval with sample mean for price column n is equal to 500 and confidence level of 95%. Observe whether the population mean lies in CI. First, I'm just declaring and giving the price column and just we are finding the mean value. Then to find CI, we are giving the condition in 95%. And then printing the CI value. Then we are finding the mean for the price. Then we are checking for the condition if the pop mean is between the 0th index or the first index. If it lies, then we are printing it as true. The next question is change the confidence level to 99%. Then we are going to observe the confidence interval for the same sample mean for price column. N is equal to 500. Here we are going to give the price column. We are finding mean for N is equal to 500. Then we are going to find our CI. Then we are printing. Then we are changing that percentage is equal to interval equal to 99%. Then we get the answer. The next question is calculate the plot, the confidence interval of 25 trials with n is equal to 500 and c equal to 95%. For price column, observe the result. Here we are giving price, we are finding mean, then sample mean, CI, then giving the plot values, color black for scatter and color bar, line for blue. Then giving the condition lies between. If lies between, we are going with green. If not, we are going with red. And we are giving label values, label names, title names, and we are just visualizing the graph. The next question is calculate the correlation coefficient using Pearson for the given table. Here we are giving the given data into the program. Then using data frame, we are giving weight column. Then finding correlation for blood pressure. Method is Pearson. Then we are printing it. Then the output is Pearson correlation coefficient equal to 0.610176. The next question is calculating correlation coefficient using Spearman for the given table. Giving the table inside, then finding the weight for correlation blood pressure. Method is Spearman. Then we are printing it. So the correlation is 0.7. The next question is calculate the covariance matrix and plot the correlation in Seaborn heat map for the given data, and we are going to analyze it. So just giving the data inside, importing the libraries, then checking for the covariance matrices. Then we are visualizing it in the correlation heat map. So this is our matrix and this is our correlation heat map. The last question, perform a hypothesis testing with Z-test. The mean breaking strength of the cable supplied by the manufacturer is 1800 with standard deviation of 100. By new technique in the manufacturing processes, it is claimed that the breaking strength of the cable has increased. In order to test this claim, a sample of 50 cable is tested and it is found that the mean breaking strength is 1850. Can we support the claim at 1% level? Z critical equal to 2.33. Okay, first importing the math library. The population mean, giving population mean, population standard deviation, sample size, sample mean, which is given, then 1% significance level, Z critical, then finding Z statistic. So Z value is equal to sample mean minus population mean divided by sigma divided by square root of n, which is 50, then printing the Z value. Then we are going to take the decision. If Z value is greater than Z critical, then printing as Z reject null hypothesis claim supported, else print fail to reject hypothesis claim not supported. Z value, the output, the Z value is 3.535533. So it is it is greater than critical value. So reject null hypothesis claimed supported. Thank you.